All right, good morning, guys. Sorry that I'm not in class for this today, but I'm going to go through the packet that you should have in front of you. So as I'm going through this, you need to be following along as well. All right, simplifying radicals. We started talking about this yesterday. So we went over the square root, the rules for simplifying square root. So I just want to get down some of the rules. So rules for simplifying square root. So if we have an even exponent, all we're going to do is divide the exponent by 2. And then everything comes out of the radical. You lose the radical completely, okay? So for example, let's look at this first one down here, square root of x to the 6. So we're taking this right here, so 6 divided by 2. Remember, it's a 2 because technically speaking, there's a 2 right here because it's square root. So 6 divided by 2 gives me 3, so my answer here is x to the 3rd. We lose the square root completely. All right, and then if we have an odd exponent. So what we came up with yesterday, one of the rules that we came up with was that if you take the exponent and subtract 1 and then divide by 2. Okay, and then the one that we subtracted, that's going to stay underneath the radical. X to the 1st is going to stay underneath the radical. So for example, right down here, we have the square root of x to the 17th. So we're going to take 17 minus 1 gives me 16. And then 16 divided by 2 gives me 8. So my full answer is going to look like this. X to the 8th square root of x. So the one that we subtracted is actually right here, this x to the 1st, but we don't really write x to the 1st. All right, so I want you to pause the video for a second, and I want you to do the next 2 and see if you get the right answer. So go ahead and pause the video and then play it once you've done. Okay, so now that you've played the video, let's do, so x to the 8th, so we're gonna, 8 divided by 2 gives me 4, so my answer here would be x to the 4th. And then here, because this is odd, I would do 125 minus 1, which is 124. And then I take 124 divided by 2. So remember, every single time, you can't forget to do that subtract 1. Also, if you have an odd exponent, then you know that you're still have a radical. All right, so then this equals 62. And so we have x to the 62 radical x. Every time there's an odd exponent, you're always going to have radical x. Okay, so now we're going to talk a little bit about cube roots. Okay, so the difference with a cube root. So cube root looks like this. We're going to have a little 3 here, so we're taking the cube root. So now x to the 3rd and cube root, those would cancel, and we would be left with just x. So whereas square root was just like this, now cube root, so basically this exponent has to match your index here in order for it to completely cancel. Okay, so it's really easy if the exponent is a multiple of 3, meaning it's divisible by 3. So for example, if I have the cube root of x to the 9th. So what we do on this is you just take the exponent and you're going to divide by 3. Just like up here, where we took the exponent and we divided by 2 because it was square root, the index was 2. Here, you take the exponent and you divide by 3. Let me change this view a little bit. There we go. Okay, so exponent and divide by 3. So here, 9 divided by 3 gives me 3, so this would be x to the 3rd. Okay, so this is with an exponent that is a multiple of 3. Remember, you can tell if a number is a multiple of 3 or if it's divisible by 3. So here is your divisibility rule. If you take a number, so let's take like 54. If I break that up into 5 plus 4, that equals 9. Can 3 divide evenly into 9? Yes. So therefore, 3 divides evenly into 54. So that's a little divisibility rule trick that you can do. Now, if the exponent is not a multiple of 3, so for example, if I'm taking the cube root of x to the 7th, okay? So on this, if I look at this, well, 7's not a multiple of 3. It doesn't divide evenly. So this is what I'm going to look at, is I'm still going to take this exponent and I'm going to divide it by 3. So I have 7 divided by 3. Well, how many times does 3 go into 7 without going over? So 3 can go into 7 2 times, right? And then I would have 1 left over. It's like remainder 1. So this, what divides evenly, comes out of the radical. That's my exponent that comes out of the radical. So I have x squared. And then this remainder 1, that's what's going to be left underneath the radical. Okay, another way to look at this is this. So I'm looking at this problem here. I can break this up into x cubed times x cubed times x. 3, 6, 7. So again, I'm just breaking down this into smaller factors. So x to the third times x to the third times x would give me x to the 7th. So this is like when you do square root of 24 and we say that breaks up into 4 times 6, we're doing the same thing here. So these would cancel, so that I would have x times x, so that gives me x squared, and then we have that one left over, so radical x. So you can think of it either way. It's the same process either way. All right, so let's look at these examples down here. So we have cube root of x to the 6, so we're going to take 6 divided by 3 because that is a multiple of 3, which is 2, so we just have x squared. All right, if we look at this one here, the cube root of x to the 16th, well, that doesn't divide evenly, right? That's not a multiple of 3. Or I could look at 1 plus 6 is 7, and 3 doesn't divide evenly into 7, so we know 3 doesn't divide evenly into 16. So what I'm going to do is I'm going to take 16 divided by 3, so 3 can go into 16 5 times, and then I would have 1 left over. So this is what goes on the outside, x to the 5th, and then this is what goes on the inside here. Okay, the other way to look at this is you can imagine, I'm sorry, that should be cube root right there. I'm not doing good at putting my cube roots in there, I'm sorry. Another way you can look at this is the cube root of x to the third times the cube root of x to the third. You could do that 5 times because that would be 15, and then 1 more would give you the 16. So you can do it that way as well. All right, I want you to pause the video and I want you to try the next 2 examples. All right, so now that you've done these, so 18 is divisible by 3, so this would be x to the 6. And then here, 55 and 3, 55 is not a multiple of 3. So if I think 55 divided by 3, oh, excuse me. All right, so if we have 55 divided by 3, that gives me 18, because 18 times 3 is going to give me 54, and then I'd have a remainder 1. So I'm going to have x to the 18th on the outside, and then cube root of x. Okay? It won't always be a remainder 1. It will either be a remainder 1 or a remainder of 2. Those are your only 2 possibilities. So, for example, let's think if we have the cube root of x to the 17th. So 17 divided by 3 would be 5, remainder 2. So then this would be cube root here of x squared, and then x to the 5th would be out front. Okay? All right, let's look at the back. So on the back, here are some examples. So we're going to work through some of these. I do want to show you in the packet this page as well. So these are your perfect squares. So 1 squared is 1, 2 squared is 4, so on and so forth. So these right here are your perfect squares, and these would be the square root of that. So for example, the square root of 16 is 4. The square root of 100 is 10. The square root of 196 is 14. Okay, so these are those, and then over here, these are your perfect cubes, because we don't do a lot of work with cubes, so I went ahead and gave you that list. So 1 cubed is 1, 2 cubed is 8, so on and so forth. That also means the cube root of 125 is 5, all right? Also, if you look over here, this is going to kind of help you. Remember when we had, sorry, this is really light, the copier just kind of did it light. So the square root of 24, you break that down into factors that are perfect squares. So we'd break that down into 6 and 4. And then the square root of 4 is 2. That comes out and leave 6 under the radical. So you do the exact same thing for cube roots, except for we're going to be looking in this column here. We're going to be looking at the perfect cubes instead of the perfect squares. So if I'm taking the cube root of 24, I'm looking, okay, what one of these numbers divides evenly into 24? Well, 8 does. So I can break this up into 3 times 8. So when I do that, if I have the cube root of 24, I'm going to break that up into the cube root of 8 times 3. The cube root of 8 is 2, and the cube root of 3, there's nothing I can do with that, so that stays under. Okay, so that's the same process. It's just instead of using square roots, we're using cube roots, so you got to be careful with that. All right, so let's try some of these. All right, so on number 1, so 24, this is square root, so 24, so that's going to be 6 times 4, right? So I'm going to square root of 24, and then I have square root of x to the 3rd, square root of y to the 5th, and square root of z to the 4th. So I'm just breaking it into pieces. So this right here we know is 2 radical 6. All right, so if this is odd, so I subtract 1. So I know I'm going to have, that's the one that I subtracted, and then I'm going to have x out front. Here, this is odd, so I'm going to subtract 1 is 4, and then 4 divided by 2 is 2, so y squared comes out, and I'm left with y underneath. And then x to the 4th, that's an even number, so 2 divided by 4 gives me 2. I'm sorry, 4 divided by 2 gives me 2, so I have z squared. So now I'm going to take all of these pieces and put them together. So whatever's on the outside, I'm going to put together. So we have 2x, y squared, z squared, and then whatever's under the radical, we have 6xy. Okay? All right, let's look at cube root. So if you notice, this left-hand column is going to be all square roots, and these are all going to be cube roots. So make sure you kind of follow that along. Oops, sorry about that email. All right, so now we have cube root. So I'm going to take cube root of x to the 4th, cube root of y to the 6th, and cube root of z to the 10th. All right, so 4 is not a multiple of 3. So if I take 4 divided by 3, that goes in one time with a remainder of 1. So this is going to have 1x on the outside for that, and 1x on the inside. All right, this 6 and 3, 6 is a multiple of 3, so this is just, I divide those, so 6 divided by 3 is 2, so y squared. 10 is not a multiple of 3, so I'm going to take 10 divided by 3, and that goes in there 3 times with a remainder of 1. So this goes on the outside, so z to the 3rd, and then I'm left with 1z on the inside. So now I'm going to put those all together. So outside, outside, outside. So let me write it over here. So x, y squared, z to the 3rd, cube root of x, z. Okay? All right, number 3. So 40, I'm going to break down 40. So 40 is 4 times 10, so square root of 40. So that becomes 2 radical 10. All right, square root of x squared, square root of y to the 4th, and square root of z to the 9th. So this is even, so 2 divided by 2 just gives me 1, so just x. 4 divided by 2 gives me squared. And here, that's odd, so I subtract 1. So here's where I subtracted 1. 8 divided by 2 is 4, so I have z to the 4th on the outside. Again, put them all together. 2xy squared z to the 4th, radical z 10. Well, actually, that doesn't look right, does it? Let's write that correctly. So that should be 10z. Okay. Remember, our numbers always come before our variables. Okay, so I want you to keep working on this. Actually, I'm sorry. Let me do one more example with you. Let's look at number 9. I do realize I skipped number 7. I don't know why. Apparently, I can't count. So let's look at number 9. So we have cube root of 27. So if I look back at my list here, cube root of 27 is a perfect cube. Sorry, right there, perfect cube. So that is 3. So this is going to be 3. And then I have cube root of x to the 3rd is just x. Cube root of y to the 4th is going to be, so 4 divided by 3 equals 1 remainder 1. So we have y cube root of y. And then z to the 5th. So 5 divided by 3 equals 1 remainder 2. So we have z on the outside and cube root of z squared. Put it all together and you get 3xyz cube root of yz squared. Okay, I want you to complete this page, and then also on the back of this page here you have more problems. So I just want you working on some problems, getting some stuff done. Try. Please don't just sit there. All right guys, we'll talk about this again on Monday.